Last class, we studied together the concept. We will study together how to draw a geological profile, making it clear that a complete geological map should include a geological plan above, a geological cross-section below, and a stratigraphic column to the left, because a geological plan can only display geological information on a two-dimensional plane and cannot fully demonstrate the distribution of geological bodies and geological structures in three-dimensional space. It is necessary to draw geological cross-sections to more vividly reflect the three-dimensional distribution and structural characteristics of geological bodies. We will study together in this lesson the methods for drawing geological cross-sections. Step 1. Read the geological plan. Taking the figure on the right as an example, we can first read the geological plan to analyze the topographic features, stratum distribution, and changes in this area, preparing for the next step of choosing a cross-section. Let's take a look at this figure. Solid lines represent stratum boundaries. Dashed lines with numbers represent contour lines. So, from this figure, we can see that this area belongs to a typical river-valley geomorphology, with high sides and a low center. Let's look at these two symbols. In the middle of the figure again, they are symbols for stratum attitude. The long line represents the strike line. The short line represents the dip line. So in this area, its strike trend is north-south. And the dip is that all rock layers are eastward dipping monoclinic layers. To determine the dip of the rock layer, besides looking at the stratum attitude symbol, we can also use the V-shape rule to determine the attitude of the rock layer. Next, let's review the V-shaped reading rule for the attitude of rock layers. Alright, let's take a look at this figure together, focusing first on the three geological plan figures circled by the teacher. On the right, here, solid lines represent stratum boundaries. Dashed lines represent contour lines. Here, the teacher distinguishes them with red and green lines. We can see that these two lines look very much like two V's, but the bending directions of these two V's are the same. Indeed. However, pay attention to the stratum boundary line, the red line, whose degree of curvature is less than that of the contour line. If you encounter this situation on a geological plan, you can infer that the dip of our rock layer and the dip of the slope of the mountain itself are exactly opposite. Similarly, looking at these two figures in the middle, when the bending direction of the stratum boundary line and the contour lines are exactly opposite, it indicates that the dip of our rock layer and the slope of the mountain are the same. When the bending direction of the stratum boundary line and the contour lines are the same, but the curvature of the stratum boundary line is greater than that of the contour lines, it indicates that the dip of our rock layer and the slope of the mountain are the same. This is the very famous V-shaped rule. Alright, let's go back to this figure. From this figure, we can see that on the west side of the Redwater River, the bending direction of our stratum boundary line and contour lines is opposite, which means that the dip of the rock layer here and the original slope of the mountain body are consistent, so it dips to the east. Now let's look at the east side of the Redwater River, where the bending direction of the stratum boundary line and contour lines is the same, but the degree of curvature of the stratum boundary line, the black solid line, is less than that of the contour line, which means that the dip of the rock layer on the east side of the Redwater River and the slope of this part of the mountain are exactly opposite. Therefore, this part is still dipping to the east. Step 2. Choose the slope line. First, make the cross-section as perpendicular as possible to the strike trend of the strata within the area. We have already seen that the trend of this area is north-south, so we should try to draw a cross-section line running east-west. The second principle is to pass through areas where strata are relatively complete and major structural parts of the map area. The third point is to choose a place on the geological map where a cross-section needs to be made when reading it. Here, everyone should pay attention that the position of the cross-section on the geological map is usually marked with a thin line, with codes at both ends, S. As the A and B sections in the figure on the right. Next, draw the topographic profile. What is a topographic profile? As the name suggests, it is a diagram that reflects the undulating topographic changes of this area. The first step, we need to draw the baseline of the cross-section, which is a horizontal line, which can also be understood as the coordinate axis we often see. Its length should match the cross-section, with vertical lines at both ends, and the scale at the top should mark the orientation and the code of the cross-section. Here, everyone should pay attention that usually our horizontal and vertical scales are kept consistent. The orientation of the cross-section diagram is generally from left to right, from west to east. The baseline's general elevation should be lower by 1 to 1.5 centimeters than the lowest contour line crossed by the cross-section. What does this mean? Alright, let's take a look at the figure on the right. The heights of the points where the cross-section line intersects with the contour lines are, respectively 50 meters, 40 meters, 30 meters, 30 meters, 40 meters, 50 meters. It can be inferred that the height of the Redwater River in the middle must be lower, less than 30 meters. So if we set the extreme elevation here as 30 meters, there will inevitably be some areas that fall below the coordinate axis, which is not aesthetic and not standard. So the extreme elevation is generally set lower than the lowest contour line crossed by the cross-section, that is, 30 meters, by another 1 to 1.5 centimeters. Looking at this figure, its scale is 1:2,000, so 1 centimeter in the figure represents an actual 2,000 centimeters, or 20 meters. So 30 meters down another 20 meters is 10 meters. So in the figure on the right, the extreme elevation we set is 10 meters. Step 2. Project the intersection points of the cross-section line with the topographic contour lines onto the corresponding heights on the horizontal line. Finally, connect the points with a smooth curve. To get the topographic profile, Step 4. Draw the geological cross-section. First, project the intersection points of the cross-section line with the geological boundary lines onto the topographic profile line. Then draw the geological boundary lines based on the dip and dip angle of the rock layers. Here we can determine its dip angle of 27 degrees from the attitude symbol of the stratum. Next, we need to draw patterns for the rocks between each geological boundary line. Many common rock patterns are displayed in the figure on the right. We use shale as an example and draw the rock pattern for shale. Then we need to indicate the age of the strata. If this area has some landmark geographical names, such as the Redwater River in this figure, we need to use vertical dashed lines to lead out for annotation. Finally, the name of the figure and legend must be noted, and the size of the legend also has corresponding normative requirements. Pay attention here. The length of the stratum boundary lines is often greater than the length of the rock pattern lines. If there are both horizontal and inclined rock layers in this area, draw the horizontal rock layers first, then the inclined rock layers. If there are any unconformities, they should be represented with wavy lines. Knowledge related to unconformities we've also covered in previous tasks. It refers to the lack of rock layers of a certain era between several rock layers. This time, we need to use wavy lines for annotation. The above is the method for drawing geological cross-sections. After class, if you are interested, you can log in to our Geological Cloud website to download various geological maps, which are all publicly available geological maps. Need to pay attention to in your future work. You are likely to encounter some non-public topographic and geological maps. These drawings detail the country's topography, landforms, and geological structures They are classified documents, and if leaked, could cause serious damage to national security and interests. So everyone must remember to strictly maintain confidentiality